Alrighty, we're back. Hopefully you got a good hypothesis written down. Hopefully you got some jollies out of working with your hydraulics, pushing them back and forth, stuff like that. Okay? Alright, so now I want to talk just a little bit about how hydraulics actually work. A little bit about your hypothesis. Now obviously if we're in a classroom situation, we'd have a few kids read those off and we'd build meaning and understanding through collaboration. But since I'm not actually physically here right now, I'm going to go ahead and explain it a little bit for you. Okay? We're going to move these out of the way, but remember we have one large piston and we have one small piston connected with a liquid. Okay? So what we're going to do, we're going to go ahead and draw this. Here it looks like I have a larger piston going on right here. And on this side I'm going to draw a small piston. Okay? Now, your hint was PSI. PSI is something that you're going to want to have to think about. Some of you have probably figured out PSI stands for pounds per square inch. Pounds per square inch. Okay? You're also going to want to keep in mind Pascal's law, that if you increase the pressure anywhere on this liquid, you're going to increase the pressure equally throughout the entire liquid. Okay? Now let's just make some math easy. Let's pretend this guy right here, the area of the plunger on this syringe, this area right here, this round part right there, we're going to say that's 1 square inch. Okay? Now this side, let's just make this one easy. Let's pretend this one here is, we'll just say 2 square inches. Okay? This side's 1 square inch, that side's 2 square inches. Okay? Now also, we're going to push down on this side, and we're going to push down with that side with 1 pound of force. Okay? So, this is 1 square inch, and we push down at 1 pound of force. This hydraulic system is going to experience 1 PSI, 1 pound per square inch right here. Now if you go to the other side right here, we said this side is 2 square inches. So here's 1 square inch right here. Here's another square inch right here. Well, if the force is distributed equally throughout the liquid, if the force is equal throughout all the liquid, it's going to push up. The liquid's going to push up with 1 pound of force right here, and it's going to push up with 1 pound of force right there. So you have 2 pounds of force coming up that the plunger is pushing up with. Oh, sorry, I got a little off my screen. But no, really, I promise that is 2 pounds of force. Okay? Why? Here you're pushing down with 1 pound of force on 1 square inch, and the pressure goes equally throughout the liquid. Well, this side has 2 square inches, so it's going to push up with 2 pounds of force. And that's how hydraulics work. You can use very little force on one side to do amazingly hard things on the other side. Okay? This can be used for hydraulic jacks to lift up cars. We already said hydraulic brakes, hydraulic accumulators, elevators, heavy equipment, trash compactors, all that kind of stuff use hydraulics. Now, we can take this a step further, and we can use this right here to make 2 different formulas as well. Okay? One formula is for force, figuring out the force that one of these pistons is going to push with. Okay? That one is output force equals the area of the large piston. Area of the large piston divided by the area of the small piston times the force applied. Now, please pause it if students need a little bit more time to go ahead and get this stuff down. And I suggest you do it not just in this form, but you write down what OF actually means. This is output force. ALP stands for area. Of the large piston. ASP is the area of the small piston. And FA is the force applied. Okay, alright, so we got the basics going on here. We can figure out the forces. What we haven't talked about yet is there's a trade-off in distance. If you notice, and you can take a look at your hydraulics again if you want to, but you have to push the little piston, you have to push it quite far just for this side to come up just a little bit. There's no free energy in science. Energy, movement, it's all under equilibrium. It's called the conservation of energy. You can't really make anything like that for free. No perpetual motions machines in this classroom, unfortunately. But that's what the trade-off is. This side pushes up so much harder, but it only goes a little distance. Okay? And for that reason, I would like you to learn another formula for how far it goes. Okay? This one is going to be DLP, the distance the large piston moves, equals DSP, the distance that the small piston actually moves, times ASP, the area of the small piston, divided by ALP, the area of the large piston. Okay? So this one here is distance that the large piston actually moves. Oh, sorry, I kind of went off my screen. This one's distance of the small piston. This one's the area of the small piston. And this one down here is the area of the large piston. Okay, hopefully that helps. Hopefully that helps you get hydraulics, what they are, how they work, things like that. In just a moment we're going to go ahead, we're going to go over one practice problem together. And then you guys are going to get some homework. You're going to work on some practice problems by yourself, trying to figure this stuff out. Thank you so much for your time and attention.